Hello.
Hello.
Hi.
Hey,
Hi.
Professor.
Hi, nice seeing you guys. How was last week? Did you guys find some relax?
Yeah.
That's good. Where is it? Oh, chat. Okay. Let's wait for a few more minutes after 6:02, probably. Ah. Yes. The homework is due on 25th. So pretty much 2 weeks. Wait, next week. Yeah, next Friday. Yeah, that's why I just I'm going to talk about it after the class begins. No, I won't consider late. Okay, it's 6 already. Before we start, I would like to ask you guys a few things first. So, first of all, homework one. I only see, thank you. I only see 10 people submit their homework one. I know homework one, I gave you guys 3 weeks because 1 week is the regular homework due time, and 2 more weeks is for, the no penalty lay policy. So a total of 3 weeks, but I only see 10 people who submitted. So any question about homework one? Because next week is the due day. I hope you guys can all complete and submit your homework before next Friday. Any question? You submit it to Blackboard. So pretty much your answer sheet will be a Word doc or a text doc, and same as your other courses, you submit it back to the Blackboard. So homework one, as I open up right here, it says matching views. So for example, the first one, you see the subject like this, and which view represent the first one. So is that A? It doesn't really look like look like A because this view doesn't match the top view of this one, right? So is that B? You do that kind of thing. Like first one is linked with which view, and then second one is linked with some view, kind of like that. So do you guys understand it? You upload files. On Blackboard, you can easily upload a Word doc or a PDF or a text. Like how do you submit your other classes homework if you don't use Blackboard? I'm confused because when I was attending Kapali, anything submitted to Blackboard is like really really straightforward. We like because like lab reports and the project reports and all the stuff we just submit through Blackboard. We barely turn in hard copies. And this year, a lot of students ask me like this semester, a lot of students ask me how do they submit their homework. So I'm confused. Is it something changed, or you just is because your first year you don't know how to submit it through Blackboard?
I think a lot of classes are using external apps.
Oh, really? Like, for example, which one?
Like Sapling Learning, My Math Lab, a bunch of different
Oh,
programs.
oh, I see. That's kind of advanced. I remember I only used some external apps for my physics and chemistry classes because they have their homework built in like that, the problem statement, and you just do the multiple choice or fill in the blank. But this one, you just exactly like in chat, just click on homework one, and then you can browse your computer and upload the file you want to. So is the objective of homework one clear? Just matching views? I'll give you like the first answer. The first one is K, is this one, because the 3 projections match exactly this subject represents. So you guys do the rest. Yeah, you can turn it as PDF as long as it's a file. So any more questions about homework one? Okay, if there's no question, I'm gonna move on. And how many of you guys have checked out the video I upload to YouTube? Because it's my first time uploading video to YouTube. I want to know if there's any question or any concerns behind it. Just let me know your feedback. If you're good, please just, okay. Yeah, please let me know in chat. If it's good, then just say good. So I don't need to make any modifications to it. Okay, thank you guys very much. Okay, the next one is LinkedIn Learning, because I mentioned it during the first time we met. LinkedIn Learning, I show you guys where to access it. Does anyone who still have trouble to access LinkedIn Learning? Or let me ask this way. Please let me know in chat how many people have checked out LinkedIn Learning. I don't care if you watch the entire video or not. Maybe you just opened up the video and closed it, but just let me know who accessed it. Okay. The people who haven't accessed it, do you know how? Okay. Sure. So if you go the CPP home portal, is this page. Normally you come here to access Blackboard, right? And at the first row, the most right, not the most right hand one, but right next to your email, it says LinkedIn Learning. And you click on it and log in with your credential. And in the search bar, you type in Solidworks. And there are two videos. One is for last year's version, 2019 Essential Training, and this one is this year's version, 2020 Essential Training. So these two videos are pretty helpful. You can I don't want to say this, but actually, if you can watch one of the videos and follow the practice and exercise they provided, and pretty much do what they show you to do, you're pretty much a master of this class already. You should get like automatically A without any problem just by completing my projects. So I really encourage you guys to watch this and just do what they show you in the video. It's very systematic. And any question to the Linda chapter videos is LinkedIn Learning. That's the same thing. They just changed the name. Because I believe before that, it wasn't showing this name. It was showing like some Linda Learning something. It's the same thing. So how many of you guys are comfortable with this LinkedIn Learning?
I just opened it for the first time.
Okay, no problem. The total length of the video is about 8 hours. You don't have to watch it all at once. You can just spread out and watch maybe half an hour per week and do the exercise, like do the mimic. So, okay. And another thing is, 2 weeks ago, the first class, the first real class we had is to make a pulley, if you guys still remember, right? And how comfortable are you guys with that pulley? Let me know in chat if you are okay to make that pulley by yourself without looking at any other references. 6 people, 7, 8, 9. Yes, speed doesn't matter, but I just want you. I just want to know how many of you guys are already comfortable with the beginning of this using SolidWorks. Like at least you know where the extrude is, and at least you know where the sketch is, something like that. Okay, good. At least half of those class are capable to do that. So who have difficulty? Like, let me know if you're saying like you're completely lost and you still can't do anything after open up SolidWorks. Couldn't find out a datum. Okay. Okay. So ignore the minor ignore the minor thing. Like if you have major problem, let me know in chat right now. Okay. So anybody have major issue saying like, I opened up Solidworks, I still don't know where to begin. I still don't know how to start. Nobody? That's great. Man, that's really great. Yeah, you guys are learning pretty fast, and just one time meet about 1 hour, and you guys are already get into this SolidWorks. Yeah. I referring something. It just reference. I mean, like you don't need my video or you don't need other YouTube video to help you to create a part. You can create the part by your own brain and by your own brainstorm. Okay, no problem. Yeah, if you need a video, you're in the right pace. The people who doesn't need a video, they're a little bit more advanced. And I just want somebody. I just want to know if somebody is really behind, and I can particularly help the individual. I don't want somebody fell behind since day one and they just keep falling behind and finally gave up. So is there anybody think he or she is falling behind a lot, need extra help? If there's no, then I assume everybody is in the regular pace. Alrighty. Okay, that's cool. That really answers my question. Really appreciate that, you guys. And also I canceled the last week's class. I apologize for that. I went to a job interview in Illinois for 2 days. So because the time difference, I really can't start the class at 6. So also I didn't bring my laptop as well. So let's begin for today's lecture. So let's look at our syllabus first. I know I mentioned at the day one, I'm not gonna exactly follow the footprint of this syllabus week by week because I stole the syllabus from other instructors. So the week one, we mentioned how to download SolidWorks and introduction a little bit. And the second week, we made the pulley. So that's the introduction to making easy models. And today, we're gonna give you introduction to how to make a drawing, like the easy drawing, not a complex one. So more and more, we're gonna cover all the content, but it just definitely not going week by week. For example, next week, we're gonna construct a simple assembly tell you guys how to mating parts. So it's not gonna be tolerances or something, or design table, something like that. But we'll cover everything. And in terms of projects, because I remember I showed you guys the engine assembly animation on day one, sorry, 2 weeks ago. And a lot of you guys saying you want to make an engine, right? So right now I want to know how many people are still comfortable with making an engine. Let me know. And those people who typed yes, you guys are pretty confident that you can complete it, right? Okay, that's good. Because one of my other class, the students are pretty scared about the engine. They think they can't complete it. And I made a proposal saying I can, because I do have the engine assembly, every component. And I said, maybe we can do, for example, show in the lecture how to make every single component. And people can just follow my footprint. So pretty much it's kind of like 90% of the time I'm holding your hand to do this engine assembly. But it's 90%, so I'll still leave maybe few components that you need to design by yourself. So do you guys think this is idea? This idea is good? Because if that is the case, you guys will lose a lot of challenges. That pretty much gonna, there's not many chance for you to, stand out or be different. Okay, sounds good. Okay. Is there anybody who already have a very explicit goal of what you're gonna make? Other than the engine? Anybody? All right, not so many. So, okay. So start from now. If you want me to show my lectures like that, like for example, making the engine assembly, at least more than half of it, type in yes in chat. I want to see how many people agree to that. Ten people? There any more? 11? Okay, if this is the case, I'll think about it. And because I know we do have a lot of weeks. Today is week 4, and we still have at least 11 more weeks. So I'll see how much weight I'm gonna put onto the engine assembly. All right, let me consider it, and I will tell you guys exactly what I'm gonna do next week. All right, so today, you guys can see I already have the Solidworks opened. So this is the subject that I just created randomly. This have no meaning, pretty much. I want to show you guys the sort of modeling logic behind before you start modeling. So when you have a part like this, like it's a very irregular shape and it's probably a little bit out of common sense. It's not symmetrical and is just pretty random. What do you think the first step is? Can somebody just let me know in chat or by audio? What will you do to do the first step?
Make a base.
What kind of base?
A flat one on the bottom.
So you're saying making a 2D rectangle?
Yeah.
Yeah, actually I see this, a solid block. So yes, I'll say when I first see this, I probably will make a solid block. Yeah, the 3 planes, this is front, this is top, and this is the right. So the reason I want to show you guys this way is not I want to test you guys, is because commonly after you get your job in industry, you will start making components. As a mechanical engineer, our job is using like 90% of the time is using a CAD to make the components and eventually assembly and to handle the full job later on. So when your supervisor, your manager tell you to create something, they won't just say, okay, here, please go make this gear, or here, please go make this pulley, and give you nothing to reference with. So normally, they will give you a 2D drawing, like a PDF, a piece of paper that has a machine drawing exactly like the drawing that we showed during the first week. Like this one. You receive a piece of paper like this, and they want you to make a 3D model based on this paper with all the dimensions. Or if you're really an entry level, they will give you a similar model because the company is making tons of those models, right? They want you to get an understanding of a model first and then make modifications to make your own project. So first of all, if you receive a model like this in Solidworks, which is the Solidworks parts file, and how do you understand this model and create a similar one with minor modifications from scratch? So this is the goal behind my question. So I have seen people saying, okay, do a scratch from the site with most features and, you know, extrude. Yes, those are all right answers because there are definitely more than one way to do a model, as I demonstrated 2 weeks ago for the pulley. There are definitely more than 2 ways to do it, but I show you guys both ways, right? So the first thing, when you have this model, you look at your feature tree and to see what kind of feature you have. And it has 3 features right here, 1 extrude and 2 cuts. And when you click on individual feature, you'll see the highlighted surfaces, which means this feature was created like this before they go into the next feature. And you can select the other 2 features at the same time and suppress them, which will yield you the first feature. And this is a block. So I know it's a little bit tedious, maybe a lot, maybe most of you guys already know this, but I just want you to know, how do you guys study, how do you guys learn how to model from a model already being created? So when you unsuppress the second feature, you'll see some material being removed, and it help you to shape this block to the a little bit to your goal, right? And the third one eventually completes your subject. And you can do it by also moving this blue line. This blue line is like a finish line. So anything below the blue line is not considered into this model. So you can see we move up the blue line and the first feature is still a block, even though this part already been completed. It has 2 more features, but these 2 are not just going to show. And this is the second step. And this is the third step. So any questions so far? Nothing? Good. So now I want to ask you guys, how many people can make this part on your SolidWorks right now pretty quick? Because only 3 features, right? 1 extrude, 2 cuts, without any more demonstration. So the second cut is like this. And the first extrude is a block. Okay, that's good. If you're pretty confident and you think there's gonna no difficulty, then you're good. Yeah, you don't need to actually try it right now, but this is what I want to see. Great. So pretty much using a software is the most important thing is confident. You think you can do it, and eventually you can do it. Yeah, don't think once you get stuck, you just stuck there forever. It is not gonna happen. All right, so let's make this one into a drawing. You see the new file icon. There's the drop-down list, and there is a making drawing from part or assembly, and make assembly from part or assembly. So this week we're gonna use this one, making drawing from part and assembly, and next week we're gonna demonstrate this one. So we click on this. Why this? Okay. Anyway, it's probably something left over from last week. I didn't clear. Huh. Okay. This one sucked. I don't want to save. Oh. All right, this time's good. Okay. So once we click that, this gonna jump right into Solidworks drawing. So yes, we're creating a new drawing. So this is a brand new drawing. That's why this window pops up. This is asking you to select a template. And a lot of you guys won't even have this concern, because when working, your company definitely has its own template. You don't have to create anything, and you just load what your manager tell you to load. So this is a built-in template for SolidWorks, like default templates. They have definitely a lot, but the standard formats will have 5 right here. So let's focus on the standard format. Right here it has ANSI, and it has BSI and other stuff, even some Ghost. I don't know. But let's just standard on the ISO format. And you guys can see right here, this is the width and this is the height that represents how big this drawing sheet is. So if you want to print on, I'll say A4 size paper, you need to choose accordingly. And also it depends on how big the subject is. So A0 right here is the biggest and A4 is the smallest. And let's just choose one in the middle. Let's do A3. This one seems okay with me. We're not gonna print it out, so it doesn't really matter. Once you choose a template, right side, you'll see this opens up automatically. And if you click anywhere, it just closed. But you still have this column right here. And this one is where it shows the projections, and you can drag them into here. And right here it has import annotations, but there's more than 3 places to import annotations. So there's no worry to do it right now. We can always do it later. So for example, you want the right view at your first one, you just drag it to here. And you can place it right here. And you will see the left side pops up is its property manual. And you can also see the projections are automatically created. So you can create as many as projections you need to show on this drawing. For example, let's place one right here, and you can create more, and you can abort anytime just by clicking yes. So this projection right now is linked to this view right here. So if you select it, and if you move this view, you see there's a relationship bounded by these two. They're moving simultaneously, right? If you want to create an independent view, you just come back here and you see the red view already being in the drawing. I've seen the drawing symbol right here. And now I want a top view, and I can just drag. I will drag a top view right here. I think somehow I link this top, yeah, somehow I link this top view with that projection. That's okay. This time I didn't link it. So now you can see I can move this all by itself. And these two are still linked together, but this one is all independent. So it's your personal preference. Do whatever you like. There's nothing wrong with it, but just let you know why this is linked and this one's not linked. So let's click on this one and view the properties. The properties right here saying reference configuration default, of course, there's no other options. And right here you can change your view. So right here, this one says right. So you're currently at right, and you can change it to front and left, back, something like that. And display state, state one, and display style. Here's multiple styles, wireframe, hidden line, and this one is hidden line removed. And let's just do, what's this, wireframe. A hidden line, removed, shade without edge. You can see this one changed with this one because right now they are referencing each other. So normally we do the hidden line. This is probably the most standard display style in the industry, unless you're making some other drawings specified by a customer. And we use sheet scale, or you can change your scale. You can change your scale to whatever the value you like. Since this template is pretty small, let's use sheet scale so it look more comfortable, right? And dimension type, you can leave it as projected, and later on I'll show you how to how to create the true dimensions. And draft quality, if you want your computer to run faster, just do draft quality. So pretty much that's it. And you got to change this one manually as well because it's independent, right? Let me turn on light. Okay, just do the same, pretty much to change the display style. And it remains the same because there's no hole or anything, so therefore there's no hidden line. So any questions so far by creating 3 projections? Okay, no questions? Okay, so I zoom out a little bit. Now you can see we have 3 projections. So this is pretty much the basic of our drawing, right? And let's move to title block. Once you imported your model, it's even more important to identify your title block because this is all the information about this drawing. This is all the meaning of what you're creating, right? So the title block, you can see there are a lot of boxes, and you don't need to worry about most of them. There are only a few ones that are really important. The drawing number. Drawing number is kind of like the driver license number for this drawing. It's unique to every drawing. You can't create a same drawing number to multiple drawings. Yeah, same company. So this one is like its own ID number, and this will be in your system. And every time anybody asks you to pull out a drawing, they're gonna provide drawing numbers. They can't provide you the drawing's name saying, "Oh, I want that 5 inches pulley. Can you put that drawing out for me?" And you're gonna ask him, "What's the drawing number?" If you can't provide it, that's definitely gonna be a nightmare for you because probably you're gonna take a whole lot of time. So drawing number is very important, unique, and title. Title is just a text, pretty much what are you creating. If it's a pulley, say it's a pulley. And if the pulley is gonna fit on a 2 inches shaft, you can say pulley and for 2 inches, like pulley, comma, 2 inches, something like that. Or you're creating a bushing and that made of bronze, you say bushing, comma, bronze. This is really personal because a lot of drawings can have the same name. And revisions. Revision means how many times this drawing has been revised. So today, this is a brand new drawing we're creating, definitely gonna be revision 0. And anybody changed it and it got re-released, it's gonna become revision A, and A, B, C, D, E, F, G follow along the alphabetic. This one is very important about the revision control because you don't want to view some drawings that was, for example, the current revision is C, and you took a revision B1 as your project, and that's gonna entirely screwed up your projects because some change already been made on this drawing and you can't see it because you didn't get the correct revision. And this box right here, it says break sharp edges. As we mentioned on 2 weeks ago, from the PowerPoint, you can see this PowerPoint is identifying is demonstrating a detail view which identifying a chamfer size, right? And I said 80% of the time, the chamfers or fillets is just to make the part smoother and is not really important because we do have a note stating that please break all sharp edges because we don't want the laborer who's installing this part hurt his hand. Manufacturing safety is pretty strict. So unless you have something to fit in this chamfer, for example, an O-ring or a gasket, something like that, you want to specify a dimensions on a chamfer because you want certain size of chamfer. But 80% of the time, it can be concluded by this note. So you don't need to create chamfers. You don't need to show all the detailed view of the potential chamfers because you have this note right here. It says break sharp edges. And finish. I think this means surface finish or surface roughness. I don't know. I never see this box showed up in title block, to be honest, because the surface finish normally go along with materials. As you want special coating or hard face or plating or whatever, it goes on your material code. And if it's talking about surface roughness, normally it goes on the note. It will be, the surface roughness will be 63 or 125, except for specified or something like that. So I've never seen this. I'm not sure what exactly should put right here. And this one right here is talking about default tolerances and the angular or linear tolerances that the default this drawing is. So it really depends on what kind of standard you guys, the company is following like ASME. The default tolerances is very similar to this one. If you can see right here, the default tolerance for 1 decimal place is 0.1, which is 100 thou, and 2 decimal places is 0.03, which is 30 thousandths of inch, and 3 decimal places is 5 thou, something like this. But you don't need to worry about it. Is your company's design protocol calls out, and that will be automatically filled in when you're using your company's template. So this one, don't worry about it. And another really important thing is right here. So normally, it only shows that 3 right here. It has 5 rows, right? Normally it only shows first 3 rows. So who draw this drawing is the originator, definitely you, right? You put your name right here and put the date and you signed it once it's ready for check. And who check it normally is your peer or supervisor and his name, and he will sign it after he complete checking. And who approved it, this means this drawing is ready for manufacturing. So this one means, this one normally is your department manager because he said this drawing is going to be released to purchasing or manufacturing because it's going to be out of engineering. So your manager will be right here, and who manufactured it, I don't care. Normally it's not going to be on the drawing, and who the QA or the QC, they have their own checklists and templates. Normally, they won't mark up anything on the drawing. The drawing is fully controlled by engineering. So when you see all the names are signed, that means this drawing is ready. And you can estimate which step this drawing is in. If all the names are signed, this drawing is complete and they already made this part. And if it's just being approved, that means this drawing is not being machined yet. Something like that. So just be real careful because once your name is on there, it's your responsibility. And if any mistake occurs, the finger gets pointed. And you don't want your department manager see, oh, I know who draw this and who caused damage, or who bring the extra cost to this project because you messed up a dimension or something. Material and weight normally don't show on this drawing because right now in standard industry, one drawing is created for at least more than a dozen material, so we won't specify any material, at least not in title block. If it's really specified just for one project, normally it's in the notes saying this particular part is just designed for this material. And the weight, normally not on the drawing because this drawing gonna be made of different materials, right? How can you estimate the weight? So let's fill out the title block as much as we could and all the areas that we care, okay? So when we right click the title block, there's an edit sheet format and you click it, and now you can see your drawing right now is sort of gone. Don't worry about it. It's because you're in the mode of editing this template. So pretty much you can modify this title block, but it's gonna take some time and it's not that important because you're gonna have your company's own template, right? So let's start with the drawing number. Let's get this modified. So from my company, normally our drawing number is one letter, A, B, C, D, or K, and followed by a 5-digit number. The reason why we set it up is because the same with the sheet template. If this part is very small, we're gonna make it from A, and that means this drawing gonna use template A because it's a small part and it's gonna be printed out in a small paper, 8x11, and that's why it's A. And if it's D, then it's gonna be printed out at a B-size paper. I believe it's like 14 times 11 or something like that. So it's gonna be a D. So this one, let's do A001. And pay attention, this is gonna be unique. So you can't create you can create a different drawing that's still using this drawing number. And the title, let's say example part, because I don't know what that part is gonna be useful. The part is kind of like a weird shaped pyramid. And revision, as we mentioned before, definitely 0. This is freshly just made. So finish, we're not gonna fill in that, or maybe we could, but I still don't know what does it mean. Like say we can do chrome oxide hard face. And material. Let's do 316 stainless steel. And draw by, I'll put my initial right there. And fill in today's date. So to be honest, I'm not gonna require you guys to fully fill this title block. Just have a drawing number, title, and your name, and revision 0. That's pretty good. That's pretty good for me. And pretty much that's what you're gonna fill in a title block when you get a job. So any questions about this title block?
Most of the stuff is stuff that your company would tell you, right?
Sorry, can you repeat it? Well,
Most of the stuff is stuff that your company would have a format to tell you, right?
yeah, of course. Your company will have a very specified format. Move your command menu like this one to the right.
No, like the top, like the top commands, right there, it moved to the right. I don't know why. It just moved to the right for some reason.
I have no idea, man. I can't even visualize your problem.
It's like, yeah, it's hard to describe. It's just everything from the top, or like it says
Okay.
smart dimensions, all that stuff. It's like,
When you have some concern, which is something I'll say a little bit weird or so, type in Google, like your command manager to the right. How to drag command manager back to top. So watch this video, 2 minutes, you'll get your command manager back to top.
all right, thanks. Sorry. Yeah, it
Yeah,
just
no
looked so
problem.
weird for the, yeah, it looked so weird. It was just started out like this.
Mhm.
Thank you.
Yeah. Any other questions about title block? Okay. Oh, and a little thing off tangent I want to mention is don't hesitate to use Google or YouTube for help. Even today, I mean, like even during daily work, I still have problem with Creo or Answers, and I use Google and YouTube a lot to figure out my question. So, for example, you want to like how to make a table in Solidworks, and it will just tell right away, 2 minutes. You know more than everybody how to make a table or something like that, you know. And I receive a lot of students email like saying their Solidworks giving a warning or something like that. Because if I encounter the problem, I know the answer, I'll tell you. But if I never encountered the problem, I really have no answers. And the best way I found out is Google, right? So definitely you can Google it and get the same solution. So just don't be shy to use the tools as your best friend. All right. So if there's no more questions, the title block is complete. And you can see right here is a return to drawing symbol right next to the close or minimize. And you just click it and your drawings are be back. And every time you need to do some modifications to the text, you just right click and edit sheet format. And you can start from there. All right. So for options, mirror. Okay. So what are we missing now? We are missing dimensions, right? The most important thing for drawing. There are definitely more than 3 ways to insert dimensions. So the first way I try to show you guys is import annotations from here. But normally I don't do that because I want to make sure my drawing views displayed okay, and then I do dimensions. But you can try that way. Maybe that's more efficient. So a second way to do it is import option. So pretty much you click on the drawing, the property manual shows up, and import options give you different options to import annotations. Yes, and smart dimensions will be 5 minutes later. So you click import annotations, and you can try different things to see what's gonna show up. Okay, so include items from hidden features and 3D view annotations. These two won't take anything because we didn't create it. So design annotations, it shows dimensions right here. However, it's only on this view, right? So if we unclick those, oh, it doesn't go away. Okay, it is good. It doesn't go away. So if we want to show dimensions for all 3 views, we can go annotation, model items, and click right here. And the source, we select entire model. And dimensions, we can definitely click all of those, even though some of the stuff we didn't create it, so it won't even show. And let's just select all. Select all, why not, right? So everything will be shown. So here we go. All dimensions are popped up. And what I mean by all dimensions is not the dimensions you wanted, is the dimensions that you created during your creating the model. Okay, if you didn't use, for example, this one to create your model, it's not going to show up. Is that clear? And you can see the display on projections is a little bit weird. It's because when we do the model items, we select all, right? And right here is nodes, surface finish, and tolerance, datum. And this is what datum targets and well symbols, everything. And right here is a plane, axis, coordinates, right? This one showed up because the coordinate system. And we want to get rid of that. You move to sketch. Or you don't have to move to sketch, I guess. Yeah. It'll take multiple clicks to get it selected, and you just delete it. Hit the delete key on your keyboard. Yep. This one as well. Get rid of the coordinate system. Alrighty. So now we have the dimensions showed up here. And any questions so far? We're not finished yet, but we're not finished with dimensions, but I want to know if you guys are all comfortable so far. Okay, thank you. So somebody mentioned smart dimensions, and smart dimension is right next to model items. What does the smart dimension do? Let's try it out. So from this edge to this point is 1, and let's create just a same dimension. So let's click yes first. So you will see 1 is dimmed and 1 is bold, right? Why is 1 is dimmed, 1 is bold? Anybody know? Any guess? Or let's do something different. For example, this angle. This angle never have a dimension on this drawing, right? It's still dim. Okay, it's pretty close by Alex saying, sorry, it's pretty close by Robbins saying is measurement. Okay, yeah, you guys are getting there. So pretty much one means this is a driving dimension and this is a driven dimension. So it's similar to strong dimension and weak dimension. So the strong dimension, which is the driving dimension, is controlling the model. This one is just a measurement. This one tells you how much is from this edge to this point, and it doesn't do anything. It has no function at all. So let's double click this. When you see the property menu at the left, you see the magnitude is dimmed. That means you cannot change it. The only thing you can change this dimension is like adding a tax. If you say reference, you're gonna show a reference after the 1.00. All right, but if we double click a driving dimension, you can change it. And let's change it from 1 to 3. So it changed to 3, but does it look like 3 from this edge to this point? This is still telling you is 1, right? So this one just number changed to 3. The model doesn't change. And if you hold control and Q, so you control Q it, why it doesn't generate? Huh? Oh, my bad. Yeah, I forgot. This 3 is constrained because this 3 is actually part of the 10. It used to be 5. If we don't change that 5, that 3 is not going to change because they're going to completely twist the model. So sorry, the bad example I chose. Let me drag this there. All right, so you see, if we change a strong dimension, okay, this is a pretty good question. Should we use strong or weak dimensions? Actually, doesn't matter, because every time you're presenting your drawing, is already a piece of paper. It's printed out a PDF or something like that, and the people cannot identify which dimension you're using. But the good practice is always use strong dimensions, because when you try to make some modifications or the stuff like that, it always reflects on your drawing and it reflects back to your model. There won't be any confusion, you know? And also, almost half of the time, the strong dimensions are not always enough. Even though your model is fully defined by all the strong dimensions, right? You still want to show a little bit more on your drawing. Sometimes, half of the time. So half of the time is always the strong dimension plus weak dimension that represents your drawing. Any question? Okay. So this is a difference between a strong and weak dimension, just to show it a little bit. Let's change it back, Control Q, and this strength to 1, right? And we want this back to 5, and Control Q, and it back to 5. Okay, one question I want to ask you guys. So for example, the total height of the subject is 4, right? 2 plus 2, that's 4. And in his projection, the right, maybe this is the front view. The front view here, from the top, this way, from the top to this step right here is 3 1/8. Why this remaining right here, there's no dimension? If I label it out by Smart Dimension tool, why this 0.87, 7/8 of an inch never showed on this drawing? And do we need to show this on the drawing? Yes, you both are right. And are there any other reasons besides these two? Yes, Michael really hits a point. It's already defined. So this model has already been defined. If we put one extra dimensions right here, what kind of consequences are you gonna get? The model will be over-defined. What does over-defined means? It means there will be a contradiction. So for example, let's come back to this drawing. The default tolerances, let's stow this one to our current drawing, okay? So let's use this default tolerances. And our dimensions, they all have 2 decimal places. So 2 decimal places have a tolerance of 30 thou. 30 thou means, for example, this 2 can go as much as 2 plus 0.03, 2.03, or the minimum, it can go 2 minus 0.03 as 1.97. So the machinist will have a total of from 1.97 to 2.03, this range, to machine this dimension. So if this is not, when we receive the part, if this is not 2, is 1.98, it's okay. They still did their job. You can't deny this part. And same to this dimension. So how much does the tolerance add up? So maximum is 2.03 times, plus 2.03, 6.04, right? So the height of this part, total height, can be as much as 4.04 and as minimum as 3.94. Okay? And why I mentioned this range? Let's take it down. 3.94 to 4.06 as height, right? And this dimension is 3.13. And 3.13 will give you the range 30 thou or plus 30 thou or minus 30 thou is 3.10 to 3.16. Am I correct? So if we have this 0.87 right here as a defined dimension, we will be in trouble. What kind of trouble? So if this height reaches its maximum, 4.06, and this value, the 3.13 value, reaches its minimum, which is 3.1, that gave you 0.96. Does 0.96 gonna make this 0.87 valid? Of course not. right? This 0.87 will have the same default tolerance at the other two decimal places dimension, which is 30 thou plus minus 30 thou, right? So the maximum this 0.87 can go is 0.84 to 0.9, right? And now we have 0.96. So the machine is going to be freaked out. Like, what am I going to do? I follow the rules, and then eventually this part is not per print. So that means it's overdefined. That's a contradictory. So just gave you guys some basic principle of which dimension should be labeled, which should not be. No. It's shaded because it's created by me. It is a weak dimension. It's created by smart dimension feature. It's not created by model items. The model items generates strong dimensions, which controlling the model. And the weak dimension is just a measurement. It's kind of like a reference. All right. Is it clear? Nope. Is no. To answer your question, the 3.13 and 0.87, they're equally important. So you can either label the 0.87, not the 3.13. Just depends on which way you modeled it, right? Because like I said, when you generate the model, the dimension you used is driving dimension, and it's gonna show up right here by the model items. So in the model, I generate this slope by 3.13. I didn't generate this step by 0.87. So that's why 3.13 shows up instead of this 0.87. Okay, there's no question. Let's move on. So pretty much today gonna be pretty straightforward because we're dealing with a very easy subject. There's no circular shape. So for example, we don't need to add anything to the note. You can see down below, there are a lot of stuff like the center line and plus minus and the degree and the diametrical. You can just, you see, you click it and then it adds up right here. You want to delete it, you just delete it. Okay, so today we're not gonna use those symbols, but I just want to tell you guys where you can find those symbols and, you know, do your own modifications to your own drawing. Yes, we're going to discuss homework 2 after I finish the lecture. Okay, so for annotation, there's still one more type of dimension I want to talk about. You know, we have talked about strong dimension and weak dimension, right? Weak dimension, a strong dimension is absolutely on the top of the pyramid, controls everything. And the weak dimension pretty much is a measurement. It displays the dimension right there, even though it still have the same meaning of the strong dimension, because after print out your drawing, it still represents the dimension of that, and it still have it's still gonna obey the default tolerance and such and such. If you want get a strong dimension angle notation manually, I have to go back to my model and change the way I model, because for example, this model, I made it by extrude and following by 2 cuts, right? If I want to show that angle dimension as a strong dimension, I need to model this differently. I need to model this starting with an angle. And that's gonna take a whole lot of time. All right. I hope that answers your question. Yes, that's why the strong dimension can change your model, right? I just showed you, if you change your strong dimension to 10, and it's gonna be expanded to a very fat part. And if you go back to your model, it's like a giant sandwich, right? Yes. So let me continue on the annotation. I want to talk about this one. So there's one other type of dimension called reference dimension. Let's not using this. Let's use this. This is a better example because we just went through the potential contradictory of this dimension exists, right? So for example, I really like this 7/8 of an inch to show up on this piece of drawing. What should I do? I can't just leave it like this, right? Because after it printed out, it had the same meaning as a strong dimension. Like the machinists will get so confused. So what can I do? All right, this call is a reference dimension. Let's put a parenthesis. So when you see a parenthesis on a dimension, that means this dimension is a reference dimension. Reference dimension meaning this is a reference. I'm just telling you it's 7/8 of an inch. So I'm not controlling by this dimension. So if this distance after machined, it happens to be 1. 1 and the 7/8 is huge difference, right? There's 1/8 inch difference. That's still okay. They're still legal because it's just a reference dimension. I'm just telling you this is supposed to be around 0.87. Even though you made it a little bit off, more than the tolerance it should be, that's okay. But if this one is not 0.87 after it's been made, it's like 4, that's definitely not okay. Because the machine is like instantly know he made a mistake by looking at this drawing, right? It should be fairly close, but just no tolerance to control it. So this is a type of dimension as well. All right. And there's other dimensions like basic dimension, and we're not going to cover right here because normally that's for more industrial thing. We in this class we will never get into that deep. All right, so let's take those off because we don't need it. And this one, you like to show it as a reference dimension, you could, but apparently we don't need it. So one more important thing is, how do you know your model is fully defined? Every time you imported your strong dimensions or driving dimensions, you still don't know if this if this drawing is fully defined or not. The best way to learn it is after you get a job, you do similar drawings over and over again. Then you will memorize which dimensions should be on there, which dimensions should not. So pretty much after you imported the dimensions, you take closer look. For example, okay, this line has no dimension, the top edge, how long that should be. Is this fully controlled? And okay, I see the 5, I see the 2, I see the 1. Okay, this one is fully controlled, right? And from here, from this step to the bottom, there's no dimension. Is this one fully defined? I see the 1, I see the 4. Okay, it's fully defined. So sort of test yourself like this, because sometimes the model, when it's getting too complicated, is not fully defined by just importing this model. So don't rely on this too much, as this button is not like once for all. You still need to have your own judgment. Okay? All right. now let's go to some detail, some, I'll say, practice. So first thing, don't have your leader line go across the drawing. For example, this one right here, the leader line goes to this point, right? But your leader line is crossing the drawing. If you have no choice, you have to go cross the drawing, you can do that. But I encourage you guys, if there's another way out, please rearrange your dimension to another way, because this is really confusing to somebody. They may confuse this to an edge line. So move this to the top. So you can see it's no longer going across, right? And this one, the leader line is way too far to this edge. So you need to manually drag it, extend it to getting it close, but no touched. And same here, drag it. And this 0.5 definitely is too wide to fit in between, right? So just put it on side. And same one right here. So just make it as much neater, as neat as possible, because it kind of leave yourself a good impression by who is viewing this drawing, you know? And also, don't ever have your annotation inside of the drawing. If you have to, make other way out. For example, make a detail view, and I'll show you how after I rearrange those dimensions. Okay, and this leader line is overlapping with the edge. All right, so right now it looks fairly neat, right? And if we would like to move a dimension, what would we do? So I believe you can hold control and just drag it into this drawing. And now you see you have the 5 right here as a strong dimension. And the 5 is still right there, and you can delete this one. So select, so pretty much hold control and drag your dimension. And it's gonna move to a different view. All right. So any questions so far? No?
No, sir.
Thank you. I always feel like if there's if nobody really answers me, I got cut off or something. Because yesterday my internet dropped and I really just talking to myself for 10 minutes and not even notice. So right now, let's do a detail view. So move to drawing. You can see there are a bunch of drawings. Model view is all these 3 views or the other views generated by here. You can import different models into a same drawing. You can have 3 or more, 5, 6 different models into a same drawing if you like to. And projected view is these 3. And auxiliary view, section view, and brick view, and crop view, all the stuff. And they even give you example. You can look at it. Normally, it doesn't really require so many different ones. And let's create a detail view. So once you click at it, and it asks you to select a center point. For example, I want to create a detail view around these 3 surfaces. So I choose this point as the center, or right here as the center, it doesn't matter. I dragged it and the circle expand. So now I have a detail view. To place it anywhere you want, you can pretty much place it out of bounds and you can still drag it back in anytime. So this is your piece of paper that will eventually print. And outside gray area is your sketch paper. So whatever you have on your sketch paper is not gonna print. They only print on this piece of white paper here. So you can have multiple stuff listed right here just as spare, because when I save this drawing, everything will be saved. Even though, like, if you have tons of stuff surround this piece of paper, everything gonna be saved. So normally, if I'm dealing with a very complicated family table part, I have a whole bunch of tables and dimensions, whatever, right here, or even sketches. And I just, when I need to make modification, I just drag what I need right here, and then label it accordingly. So that's complete. And if you click on it, that little circle that open up the menu, the property menu, and you can change your style. Change it to broken circle. This is similar to the PowerPoint, right? It's broken circle, have the A in there, and with leader. Normally, I like with leader because it's more, I'll say more obvious to see, because you have a leader right there, and you can add a text. Normally, I do just say detail A, so you can see it from 10 miles away. And right here, those are a bunch of stuff, no outline, with outline, something like that. And the pin position or not, just play with it. And oh, sorry, move too fast. And option right here is import annotations. If there's any annotation, you can do that. But unfortunately, in our case, there's no annotation among these 3 surfaces. So even though I clicked it, nothing gonna show up. And right here, wireframe, or you can do shade. But let's just keep consistent. Do the hidden line visible. Okay, this is the most standard way to do a machine drawing. And the scale, you can change it if you like to. And the other thing is just like standard views. So let's drag it right here. And this is the text box. You can see right now it says detail A, because we add a text of detail, right? And let's just delete one of the detail. Right now is detail A. Okay, and you can do whatever you like with it. And also, if you want to add an isometric view, right here, isometric view, you can do that if you like to. Just being nice, give an overview to a machinist, saying this is the final part should look like. And you can do that, and you can adjust the scale, because it doesn't really matter. It can be really small, right? And let's put it in the corner. And as I mentioned 2 weeks ago, normally the drawing, pretty much 95% of the time, the drawing will have a note section. And how to do that, we need to manually create a table, which by right click, and there's a table right here, say general table and a bunch of other tables. If you want to have like Excel-like table, do the general table. What do you mean by bolden the dimension outline? For example, like this 6 right here is already pretty dark. The part outline, what do you mean by outline? I'm sorry, that outline really confuses me. Are you talking about dimension itself? Or talking about the leader line? Or let me do this table first, because we're pretty close to conclude our lecture. And then you want to ask me that, let's stay after. So once you right click table and want to generate a general table, and the table templates is right here. Normally your company will have a bunch of table templates. like note table, family table, and subassembly table, something such and such. And you can open up a template. Otherwise, you just do some modifications right here, and you click back, click yes, and click back. This is an Excel table, just very similar to Excel, and all the settings are all the operations are similar to Excel as well. You select the entire column by click the header, or you select a row by clicking like it is the header, like the most left column, or you select the whole thing by just drag. And if you want to, for example, change the width or height, is formatting, and there's a width and height, stuff. Let's make this really small. So right here, we can just input numbers. So just input here whatever you want this part to make, like material is like material is like what, carbon steel, and here you can change it. Please see notes. Something like that. You know, anything can be fit on right here as a note. And the machinists will pay attention to this because they're gonna read all the notes before they start machining this part. So pretty much, this is a very, very simple drawing. Are you guys okay with making a simple drawing like this?
Yeah, I think so.
Cool. Good to hear that, man. Thank you. Anybody have concerns? Okay. Yeah, please. If you try to follow the video and you make it successfully, that's very great. And if you think you still can't get it by following the video or Google or YouTube or LinkedIn Learning, let me know. I don't mind hold your hands, but you know, we're engineers, right? Okay. If there's no question, I'm gonna talk about homework 2 a little bit, because homework 2 have no instructions, and I would like to tell you guys what to do. Homework 2 already posted on Blackboard. You can find in assignment, and it also has 3 weeks starting from now. Homework 2 solution will be posted next week. So if you want, do the homework independently and test yourself to see if you can get the correct answer, please complete it before next Thursday, or just don't open up the solution. If you want to copy it off, I have nothing to stop you. So homework 2, there are 6 models. You can see 1, 2, 3, 4, 5, 6. 6 models. Your job is to hand draw 3 projections. So similar to homework 1. Homework 1 is mix and match, right? So the projections are already been provided to you. You just need to label the number and the letter. So homework 2 is giving you the model, but you need to create this for all 6. So total 18 projections on piece of paper, or you can do it by Solidworks by modeling these models and then do the drawing as I just showed, even though there's no dimensions. So pretty much it's just gonna show 3 projections and then, you know, save as PDF and submit it to Blackboard. So either you do it by hand, take picture of your work and submit it to Blackboard, or you do it by Solidworks. It's totally up to you. I'll say do it by hand. I can pretty much do all 6 by hand in like 3 minutes. But if you want to challenge yourself, the modeling skill and the drawing skill, do it by SolidWorks because it's really easy to model. And forget about the black lines right here. This is just to show you those cubic are equally, the equal size of each cubic. So, any question? Yes, just 3 faces. Exactly. Front, right, and top. Yes, yes. You need to show the hidden line for the holes. For example, this one, it has a hole in the middle, right? So top view, there's no hidden line. Well, there is hidden line for those edges, but there's no hidden line for hole. The front view, you show the hidden line for this hole. So very similar to homework 1. If you guys can see here, homework 1 have all the hidden lines as well, right? Okay, so kind of like a DLC for homework 1. So just same rule, same pattern, and up to you which way to do it. But pay attention, if you take a picture or scan it, making sure those are all in the same page. For example, if you take a picture, right? It take maybe 6 pictures because 3 projection view per page, kind of like that. If you can fit all 18 into 1 page, that's fine. That's fine with me. But if you cannot fit it, making sure you create the file like a single file. Don't create like multiple pages file. Like post those pictures into 1 Word doc. I don't mind have like a multiple pages Word doc, but just make it a single file, okay? Because Blackboard can only submit 1 single file. And if you want to do it by SolidWorks, if you save it by PDF, make it a multiple page PDF. Don't make multiple PDFs. Is that clear? Okay. If you have no question about either homework 2 or today's lecture, you're good to go. And any question, please stay after, and I'm here to answer it. Thank you, guys. You guys have a wonderful night. Have a good weekend. Yes.
Professor,
Yeah.
If you go to the drawing, and if you look at the notes and you have different materials, like how do you differentiate that with like what the machine is looking at? Like how does he know which material it is for which part?
Do I have different material now?
No, I mean like if you have a part and it's made out of different materials, and even though you list them, like do you still mark them like on the
on
the part?
Okay. So that's why when I go over the title block, I say the material block right here normally don't show on this drawing because this part can be made of so many different other materials, right? So when getting a company, the material should be labeled on build material, not the drawing. This one is labeled right here because this is Solid default template. So I made this as an example, and just saying the note can be stated like this, like the material is whatever, but it's not like, you know, it's not like a guideline, like you should say this. So pretty much in industry, you'll never face a situation that your drawing cut out a material and your bill of material cuts out another material. That kind of discrepancy is a mistake.
Thanks.
Yeah. Yes, the lecture not on Blackboard. I'm gonna upload to YouTube, and you can have the YouTube link from announcement. I already posted, so just follow the channel, and all the future recordings will be on there. I will post the lecture recording probably tomorrow. Definitely before weekend. Thank you. You too. Any questions? If there's, thank you. If there's no question, I'm gonna bounce, and you can ask anything through email.